Welcome to EDU3339. Today we're going to be talking about problem solving and planning for mathematics instruction. Our goal for today's video is to discuss problem solving, that is really concepts versus procedures, and cognitive levels of mathematical tasks. Let's start by talking about problem solving. In Chapter 3 of our book, there was a discussion on a shift in the role of problems. I remember several years ago when you only saw problem solving or word problems maybe at the end of a chapter in a textbook or at the end of a lesson. Now we're seeing more and more word problems or story problems that require children to actually think about the mathematics that they are doing. That's a real shift in those role of problems. But there are processes for teaching problem solving. I want you to think back when you were in school, middle school, high school, and think about how your teacher taught you to solve math problems. Was it through concepts or was it through procedures? What I mean by that is, did you fully understand what you were doing when you were solving a problem, or were you just following a procedure? I'll give you an example. Finding the volume of a particular three-dimensional shape, let's say a cube. If you were asked to find the volume of something, would you totally understand that the volume is what is inside of that figure? Or do you just know that it is length times width times height? The concept is knowing exactly what you're doing, and the procedure is like following a formula, knowing how to do it. So let's look at our types of problem solving on this slide. When you're teaching for problem solving, you actually teach the skills and then provide problems to practice those skills. So we're teaching students how to solve those problems by using word problems and figuring out what the skills are. If we're teaching about problem solving, there's actually a process. First, you have to understand what the problem is asking. You have a plan, you carry out the plan, you look back to see if you've actually answered the correct question. Now, a skill is usually involved in that, but if we're teaching about problem solving, it's more teaching how to solve the problem using the steps. Then we can actually teach through problem solving by teaching context through real context, real world problems, situations, models, and exploration. That's kind of how we want to do this. We want to learn how to teach through problem solving. So here are three problems. The question is, which of the following can be used in a problem-based approach to teaching? So take a look at these. The answer to that question is all three. It depends upon the teacher. I can take A, 42 minus 19, and turn it into a problem-based approach by asking the student to show me the answer to this problem using words, numbers, and pictures, because that's going to show me that the student knows the concept. The same way with B and C. I think we can see how problem C would be really doing math. Problem B, we can still just use a procedure. But depending upon the teacher and the way the problem is asked, it can actually lead us to higher order thinking in mathematics. So what are the features of worthwhile tasks? Well, they really don't have a lot of memorized rules or methods to solve, so the student can choose the way that they solve the problem. They don't have a perception that there's one correct solution. Now, I know what you're thinking, mathematics is absolute. Yes, it is. But you can attempt to solve a problem in any way and get to a correct answer. However, there's not one way to get to one solution. It offers boundaries or constraints, so I might tell you you need to use models to solve this problem. And then it has the potential to provide new mathematical insights or knowledge. Those are features of worthwhile tasks. Now let's take a look. Chapter 3 discussed the 4 levels of cognitive demand. So we're going to break these down right now and learn a little bit more about them. We have 2 types of low-level cognitive demand, memorization and procedures without connections. And that just means it depends upon the prior knowledge of the student as to whether or not they can solve the problem. The high level are procedures with connections and doing mathematics because it builds onto prior knowledge. Let's take a look at these separately. First, the low level memorization. It's basically just a reproduction of facts using formulas and rules. No explanations are required. You'll see some examples in a few minutes, but I'll give you one. 9 times 6. We know that's 54. I just reproduced that fact. I really did not have to think about math at all. I just have to say what I've memorized. How do you find the area of a rectangle? Well, I multiply length times width. I didn't really use math at all. I just know the formula. And I could multiply. What if my length was 9 and my width was 6? There I go. I just reproduced that memorization without really doing math at all. Then there's procedures without connections. Requires algorithmic thinking, but the focus is on producing the right answer and no explanations. And I don't mean explanations of how did you solve this problem, but thinking more deeply into the question on, can this be repeated with other shapes or other problems, or think about how this could be described if you were modeling it using blocks or drawing it. Procedures without connection. Then there's procedures with connections. It does require algorithmic thinking, but the tasks are focused on gaining an understanding of the concept. Now this is your higher level math, and it does require some degree of cognitive thinking. Then there's doing mathematics, which is what we really want to get to. It requires students to work through a problem rather than just follow the procedure. It doesn't always require algorithmic thinking, and it does require understanding the mathematical concepts, and it does require explanations. So let's take a look at some examples of these. So here's some examples of the memorization. What is the rule for multiplying fractions? So we would expect our students to say either multiply the numerator times the numerator and the denominator times the denominator, or multiply the 2 top numbers and then the 2 bottom numbers. I just memorized how to do it, but I didn't really do any math with that. That's memorization. Next, procedures without connections. So the teacher gives me a problem, 2/3 times 3/4, or 5/6 times 7/8. I know how to do it because I know the procedure. So I know it's top number times top number, bottom number times bottom number. So I get 6/12 for the top one. I get 35/48 for the middle one. I have just done math, but there's no connections as to what that means. Okay? What that means is basically I have less than 1 multiplied by less than 1. What is that going to give me? I'm multiplying a part of something times a part of something. Need to understand what that means. Again, that's procedures without connections. Next, we have our higher level demand. So this is procedures with connections. Here's the problem. Find 1/6 of 1/2. Now notice how this is asked. This is still a multiplication question because of in math means multiply. So really this is 1/6 times 1/2. But look at the way the question is asked. Find 1/6 of 1/2. Use pattern blocks. Draw your answer and explain your solution. So There's the answer. First you take half of the whole. Okay? So there's the half. Then they're dividing that into 6 parts and finding one of those parts, and then taking the answer as a whole again. So 1/12. So 1/6 of 1/2 is 1/12. Or 1/6 times 1/2 is 1/12. Look at the difference between the problem that we just did without connections and this one. For some of you, your mind is a little confused right now. And the reason why that is because you weren't taught this way. But you're going to find the more you do math, the more you need to understand it deeply. And that's what the higher level demands require. So that's procedures with connections. Now here's doing math. So here's that multiplying fraction question again. But this time we ask the students to create a real-world situation for that problem. Solve that problem and explain the solution. So a possible student response: for lunch, Mom gave me 3/4 of a pizza that we ordered. I could only finish 2/3 of what she gave me. How much of the whole pizza did I eat? Look at that explanation. I drew a rectangle to show the whole pizza, then I cut it into 4ths and shaded 3 of them to show the part Mom gave me. Since I only ate 2/3 of what she gave me, that would only be 2 of the shaded sections. So basically they ate half of the whole pizza. That kid would really understand what 2/3 times 3/4 means. And that is called doing mathematics. So now let's review. We talked a little bit about problem solving, concept versus procedural. We're going to practice more of those, but the concept is understanding the reasoning behind the numbers. Procedural is basically just knowing the formula and following the numbers, but not really knowing the meaning behind the math that you are doing. So we're going to learn to approach problem solving in this course in a conceptual way. Then we talked a little bit about the cognitive level of mathematical tasks. There are 4 levels: memorization, procedures without connections, procedures with connections, and doing mathematics. All of these types of questions can be used in a classroom. However, there needs to be less of the top 2 and more of the bottom 2 in order to bring the students into critical mathematical thinking.